brain is very much concerned with keeping track of time. So again, the part of the place in the body that keeps track of how long is a day, like when should you expect the sun to be rising, and when should you start increasing levels of certain hormones or decreasing levels of certain hormones, that area resides in the brain. So the suprachiasmatic nucleus is the clock, the internal clock that keeps track of how long is a day, when should you expect the sun to be rising, those kinds of things. And it adjusts all kinds of things in the body. So suprachiasmatic nucleus.
Could you explain what that is?
Oh, it's this tiny little group of cells. It's right above your optic chiasm. So where your optic nerves go into your head, below your brain, those optic nerves meet on your midline and cross and form chiasm. And then right above it is a little group of cells that have a very, very neat cellular mechanism to keep track of about a 24-hour cycle. So if you cut out that little nucleus and throw it in a dish, those neurons will be producing chemicals at a rate that goes up and down in a 24-hour time cycle. So they know about 24 hours, and it has to do with transcription, translation. It's going back and forth between DNA and proteins. But that whole process is set up to occur around 24-hour cycle. And then because it's right above the optic chiasm where the visual information is coming in, when light hits your eyes in the morning, in particular blue wavelengths of light, it travels up to this nucleus. They have electrical impulses. It releases neurotransmitters onto chemicals onto these neurons in the suprachiasmatic nucleus, and it resets the start point. Say, now we're at the start of a day. Now start your cycle again. If you put people in darkness, put them in a cave, that suprachiasmatic nucleus will still go and keep about a 24-hour time scale, but it'll be desynchronized with the actual rising of the sun. So if it doesn't have that input, that visual input, it kind of becomes free running on its own.